Going on, guys, let's look at this problem right here. This question is asking, assume that a digital system has two 8-bit registers R0 and R1. Give the microops required to implement the following. The first one is asking, complement all the odd numbers bits in R0. Assume bit 7 is in the MSB, 7 is the MSB, and bit 0 is the LSB. The second part is asking, complement all even numbered bits in R1. Assume bit 7 is in the MSB, and bit 0 is the LSB. Now let's see how to do that. We have two 8-bit registers R0 and R1, and we are required to find the microops. Now let's look at the truth table for AB. Okay, AB, truth table for AB, A XOR B. The truth table will look like this: 0 0 1, actually 0 0 0, 0 1 1, 1 0 1, 1 1 0. So we can observe that when one of the input to the XOR gate is 1, the output complement of the other output is the complement of the other input. Okay, and when one of the input is 0, output is just other input. So to complement of odd numbered bits in R0, we just have to do R0 coming from R10 XOR 1 0 1 0 1 0 1 0. So required micro operation is A coming from A XOR B, where B is 1 0 1 0 1 0 1 0, and A is R0, and this is for first part, let's say A part. Now let's look at the second part. For the second part, R1 comes from R1 XOR 0 1 0 1 0 1 0 1. So required micro operation is A coming from A XOR B. Here B is 0 1 0 1 0 1 0 1, and A is R1, and that's it. This is A part, this is B part, and that's how we do this kind of problems. I hope you guys find this video helpful. Thanks for watching, and if you're trying to learn digital logic design 2, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.